Today we're going to be talking about solving inequalities. And inequalities are solved just like equations. Just unlike equations, we're going to have an infinite amount of possibilities for our solutions. So our first example, I am going to subtract the 4y over, and I'm going to subtract the 2 over, so that we end up with negative 5 less than y, or flipping it around, y is greater than negative 5. So graphing the solution on the number line, you go to the value negative 5. Since it's not inclusive, it's an open hole. And since y is greater than it, that arrow there tells me all of my possible solutions. Now there's a new type of notation that we're going to be using a lot this year, and it's called set builder notation. And it has a bracket, and then your variable, a little line, and then the inequality. And what that means is y, your answer is y such that y is greater than negative 5. And we're going to be using this a lot when we get into later chapters, so I'd like to introduce this to you guys now. Okay, solving this equation, and I have a little reminder here. When we multiply or divide by a negative, we must switch the inequality symbol. Now, I'm going to do this one all without a calculator. Remember, that decimal as a fraction is negative 3/10 p. Now, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by negative 10/3. Don't forget to switch that inequality sign. When I multiplied by 10/3 over here, or negative 10/3, that canceled out that fraction, so I'm just left with p. So now that makes our life a lot easier because the 3 and the 12 cancel to be a 4, and I get negative 40 less than or equal to p, or p is greater than or equal to negative 40. Okay, so I give us our number line. Now we need to think of an appropriate scale for the bottom. Negative 40 is a pretty big number, so I might go by 5s. So I'm going to go, if I go by 5s, if I number every other one, that's going to tell me that I'm going by 5s, but I'm not writing as much, which is kind of nice. So it tells me that each one is going by 5s, but I'm not writing as much, so we don't have to worry about taking up a lot of space and it looking messy. So p is greater than or equal to, so greater than or equal to filled in dot, going that direction. Now again in set builder notation, p such that p is greater than or equal to negative 40. Okay, solving this inequality. Get rid of that 2 in the bottom. So I multiply both sides by 2. I multiply this side by 2. Now, even though the x is negative, I leave that as negative 2x. I don't switch the sign because the 2 wasn't negative. You only switch the sign if the number you're multiplying or dividing by is negative. Okay, then I subtract x from both sides. Now, x, since I'm dividing by negative 3, I switch the sign. X is less than 7/3. So let's come up with our good scale. So let's go by thirds. So this is 0, 1/3, 2/3. That would be 1. This is the same thing as 2 1/3. So I have an open circle here. X is less than, so I'm going to the left. And our set builder notation, okay, our next example. Let's distribute the negative through, so we have a negative 15d plus 35 greater than 6d plus 42. Now I'm going to add the 15d to both sides so that my coefficient in front of my variable isn't negative. So if I add 15 to both sides, we get 21d. If I subtract 42 from both sides, we get a negative 7. Now divide by 21. Now be careful here. A lot of you guys are going to say that's negative 3. It's negative 1/3. Writing it so that the variable's on the left, okay, so it's numbers less than negative 1/3. Okay, so let's make that 0. Let's go by thirds again. This would be negative 1. That'd be negative 2. Negative 1/3 is there. It's an open hole, and I'm less than, so I'm going to the left. Our next example. Xavier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $1.59. So he's already spent $1.59. If gasoline at this store is $2.89 per gallon, that's some cheap gas. How many gallons of gasoline to the nearest tenth of a gallon can Javier buy for his car? So he has at most 15. So the amount he has to spend has to be less than or equal to 15 because we can't go over $15 because that's all he has. He's already spent $1.59. Gas is $2.89 per number of gallons. Okay, G, let's define our variable. Tell me what G is standing for. Gallons of gas. When I subtract 159 from both sides, I divide by 289, and I'm doing this all in the calculator. It's okay for you guys to have your calculator in numbers like this. So he can buy less than or equal to 4.64. Now go up and look. We went to the nearest tenth. So 4.6 gallons. So he can buy at most 4.6 gallons of gas. Okay, as I was talking about earlier in this section, there's two special types of notation that really leaving this class I want you guys to know. Set builder notation we're going to be using a lot in later chapters when we talk about these things, domain and range. I've kind of already talked about that. But interval notation is putting numbers in between essentially brackets or parentheses. When you put a number in parentheses, means it is not inclusive, meaning I don't count the points that are on those endpoints. When we have it in brackets like that, it means that I do include the endpoints. So looking at this inequality is x is greater than negative 3. As we already talked about in set builder notation, it's x such that x is greater than negative 3. Set builder is kind of easy because all you have to remember is that it's these types of brackets. Now, in interval notation, you're giving me essentially the interval for x. We use a parenthesis because we don't include negative 3. So it's just negative 3, comma, and then our endpoint, it goes on forever, so that's going to be positive infinity. So this is not a coordinate. What this is that's the start point. Okay, it tells me that our interval starts at negative 3 and goes forever to infinity, which is an endpoint. When putting things in interval notation, parentheses means I don't include those endpoints. This negative 3 is not part of my solution. It's not because it's an open hole. Negative infinity we can't, or positive infinity even, we can't include because they're not values that we can stand on. So for infinity, we always have parentheses in there. Okay, this next example, its x's are greater than or equal to, I apologize. For our next example here, x's are less than or equal to positive 1. So again, our set builder notation is easy. X such that x is less than or equal to 1. Now, interval notation. You could think about it as this value there. I think about it as a start point or the smallest value. What's the smallest value that's part of this solution? Well, that's technically negative infinity. What's the largest value? Our largest value is 1, and we stop at 1. So I actually have an incorrect notation back here. It's not a parenthesis. It's inclusive. I'm including 1, so it's a little bracket that looks like that. So it tells me, this notation here tells me that our answers are from negative infinity to 1. Okay, there are your lesson questions. Please make sure these questions and your summary is submitted on time.